Hello viewers on YouTube. In this video tutorial, we are going to provide a solution to the problem we have before us right on the board. So we are required to state whether or not the limit you are looking at exists. So for we to be able to tell whether a particular limit exists or not, then the following condition must be satisfied. That is, the limit as the variable approaches the limit point, which is 0 in this case, from the left hand side of the function f of x, which is this entire rational function in this case, then it must be equal to the limit as the variable approaches the limit point 0 from the right hand side relative to the function f of x. So if this condition is satisfied, then we said that the limit exists, and otherwise the limit doesn't exist. So this is exactly what we are going to prove out. So keep that in mind. I need to get it a bit so we can have enough space, but this is where we are coming. Now, before we actually proceed on satisfying the condition, let's pay attention to the function. We have 16 multiplied by the absolute value of x minus 5 times absolute value of x minus 9x plus 10 divided by 12 times absolute value of x plus 15 times absolute value of x plus 5x minus 4. So what should be our first step in this case? Well, we have absolute value, which means we need to understand what the absolute value of x is. But before we actually dive into that, these are like terms. So we can actually apply the equations to them. This is 16 times absolute value of x minus 5 times absolute value of x. We can subtract them as we have a negative sign to be connecting them. For those who might be wondering, if we let absolute value of x to be a constant like k now, for instance, it will become 16k minus 5k, so which we can actually add or subtract them, so they are like terms. So let's do that. That should be our first step. So we have the limit, as x approaches 0 of 16 minus 5. That will give us 11 times absolute value of x minus 9x plus 10. Excellent. Then we have our division. Is that straight enough? Let me do it again. Divided by 12 plus 15, 12 absolute value of x plus 15 absolute value of x. But 12 plus 15 is 27, so we have 27 times absolute value of x plus 5x minus 4. Perfect. Now at this point, we now have just absolute value, absolute value of x in both the numerator and denominator. So we have been able to make the rational function, we have been able to make it more simplified. Now, what exactly is absolute value of x? It is important we understand that, most especially when we are dealing with limits. Let's begin with absolute value of 2. What is it equal to? Basically, what absolute value helps us to do is that it helps us to get rid of negativity. So if the value inside the absolute value is positive result, a positive value to say, then the result will be positive. However, if it turns out to be negative, it has to provide a result that is still positive, because it has to get rid of the negative side. Am I communicating? For those who learn physics, or for those who are taking physics class, you can see absolute value as a distance and not displacement, which the direction doesn't matter, but instead the magnitude. Perfect. Now, when the input turns out to be a variable and not a constant or a value or a number, then the absolute value of x turns out to be two different results. It's usually equal to plus or minus x. However, to make it in a more generalizable way, they represent the result of absolute value of x in a piecewise function. That is, we now have it to be equal to negative x when the value of x is less than 0, and it is said to be equal to positive x when the value of x is greater than 0. Am I communicating? So when the input is not a constant, but it involves a variable, then the result will be plus or minus x. Are we here? And if you want to write it in another form as a piecewise function, this is how we are going to express it. However, this is what we're making use of, because that will help us to evaluate this problem. Am I communicating? This is when x is less than 0. This is when x is greater than 0. Perfect. So having done this, let me get rid of this one. So I'm just saying absolute value of x implies this. Now, basically, we want to use the result we have here to evaluate this limit. Remember, we said that the first thing we consider doing in order to satisfy the condition we made mention of earlier is that the limit as, okay, let me put that somewhere around here, is that the limit as x approaches 0 from the left hand side of the function f of x must be equal to the limit as x approaches 0 from the right hand side, where it is positive. Now, as x approaches 0 from the left hand side, what are the possible values of x? That will be this one. You understand? And a simple example of that is negative 0.00001. That's a good example of a value that is approaching 0 from the left hand side. So far we have a less than 0 value. It must be negative. Am I communicating? Because immediately after 0, the next value will be having are going to be positive. So values that are approaching 0 from the left hand side has to be negative infinity. Am I communicating? However, if we are considering it in relative or in relation to absolute value of x, then we will be considering negative x as our input. Am I communicating? We'll be considering negative x as our input. Because with the absolute value we have in that function, the input has been split into two, which is minus x and positive x. Now, for you to know which to use, that will depend on the limit point. Am I communicating? If the variable is now approaching the limit point from the left hand side, you are considering using minus x. Are we here? Because that is the valid value of x. That is the valid input for this range. Are you getting my point? Perfect. Also, if the limit is approaching if the variable is approaching the limit point from the right hand side, which is positive value, then you are considering using this as the variable or as the input, because that is the valid input for this range. Are we together? Perfect. Or do we regardless? So now, therefore, if we want to evaluate the limit as x approaches 0 from the left hand side, then we got to replace the absolute value of x entirely with minus x, and hence we now have the limit as x approaches 0 from the left hand side of 11 times minus x minus 9 times minus x plus 10 divided by 27 times minus x plus 5 times minus x minus 4. So if we simplify this forward, we will now have the limit, that's so long, we will now have the limit as x approaches 0 on the left hand side of 11 times minus x is minus 11x, minus 9 times minus x is positive 9x, plus 10 divided by 27 times minus x is minus 27x, 5 times minus x is minus 5x, to minus 4. Now if we substitute 0 as the input, then we realize that this will end up being 0, this is 0, this is 0, this is also 0. And left over is just 10 divided by 4. So this clearly means that eventually, well, I think I can get rid of the question at this point. So eventually, the limit as x approaches 0 from the left hand side of negative 11x plus 9x plus 10 divided by minus 27x minus 5x minus 4 is now equal to 10 divided by minus 4, which is simply minus 5 over 2. So that is the result we have when we evaluate the limit as the variable x is approaching the limit point from the left hand side. So we need to also determine what the behavior will be when the variable is approaching the limit point from the right hand side and compare our results and see what happens. Well, all I need is just to get rid of this one. Oops. So now we basically want to consider evaluating the limit as x approaches 0 from the right hand side, so positive. Okay, please, for those who might have lost, I've changed the 0 to positive, as you can see where I highlighted. So now we basically want to replace the absolute value of x with positive x. I'm not communicating because that is the valid input. Okay, that's the valid variable in relation to a limit point. So now we have the limit as x approaches 0 from the right hand side of 11 times x minus 9 times x plus 10 divided by 27 times x plus 5 times x and minus 4. So eventually we're going to have the limit as x approaches 0 on the left hand side. Okay, well, since the variable is positive entirely, this will still be what it is. It's just that we won't have absolute element. So this is just 11x minus 9x plus 10 divided by 27x plus 5x minus 4. Excellent. So now it's time to get rid of this one. We don't need it anymore. So simplifying forward, upon substituting the limit points, then we have 11 times 0 minus 9 times 0 plus 10 divided by 27 times 0 plus 5 times 0 minus 4, which is simply equals to 10 divided by minus 4. And notice that that would end up being the same as negative 5 over 2. Well, notice that the result we have above turns out to be the same as this one. And clearly, we can conclude that the limits exist. And that's how you can easily tell whether or not a particular limit exists in a certain problem. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now.